Hello, everyone. My name is Hugo Dorado. I'm a researcher from the Biodiversity Seed Alliance, and the topic of this presentation will be variable selection and transformation criteria. This material is part of a training course called Foundations for Data Analysis and Data Mining in Agriculture that's being developed between the Alliance of Biodiversity Seed, the University of Illinois, CIMMYT, and the CCAPS project. This presentation emphasizes the pre-processing of information once it's integrated to several databases. And by doing this, I would like to answer the question that have been posed by several researchers about how during the first inspection they can take a decision about the variables that have to be removed or the ones that have to be transformed. There are different reasons why this pre-processing phase is important before doing analysis. The first one is that many of the databases still do not have the proper structure to be introduced in a software for analyzing data like R, Python, or SPCs. Taking that into account, it's important for our time to be invested on structuring that information so that it can be inputted without any problem to one of these softwares and continue with the analysis. Also, there are variables that can be should not be included in the research that we are performing. So it would be important to have a conversation with the people that know about the topic that help us to identify the importance of keeping some variables and getting rid of others that won't help in the future. Some of the variables can also have different scales or would require some specific sort of transformation, so it cannot be used in the way that it was included originally in the database. Also, some variables, due to privacy issues, should not be taken into account, like names of the producer, telephones, or emails. During the first revision of a database, we could ask the following questions in the moment that we are analyzing each one of the variables and deciding if we are going to remove, keep, or apply a special procedure to each one of those. The first one is to know if the variable helps to the research objective. In this case, it's important for us to define what we want to do. If it's a prediction, identify producers that are under the same climatic conditions, or assessing the factors that affect the most appearance of plagues or diseases in a crop. So based on that research objective, we could begin to discharge variables that will not contribute to the analysis. We could also ask ourselves, is the system of units that's in each one of the values in that variable is uniform? In that case, it's important for that unit to be standardized. For example, if we're assessing a variable like the area, and there are values in hectares and square kilometers or square meters, we have to choose a procedure to standardize all those variables within one same unit. If we do not do it, probably this is going to generate problems in our data analysis. Finally, there are variables that require a special transformation, like, for example, the dates or category variables that have many different categories included in them. In that case, in the case of the dates specifically, there are some conversions that we can carry out in order to have a numerical value for a category that can be inputted in the model that we are analyzing. In the case of category variables, we also have to choose if we can group some variables in order to try and facilitate the assessment of those relationships that we are interested in knowing. The first criterion to remove a variable from our database would be to remove all personal data, since these are variables that will not help in the future for our data analysis. Instead, they could generate problems with privacy issues. Therefore, variables like the name of the producer, the ID number, telephone, email, and addresses could be removed from the beginning of the pre-processing. Another of the criterion used to remove variables in the dataset would be counting missing data, because we don't want to maintain variables that have a lot of lost information. And despite the fact that there are some methods to estimate those values, we should not abuse of those, since they could affect the quality of our analysis model. There's no threshold that defines a percentual value based on how many missing pieces of data we could keep so that a variable can be maintained in our data set. However, in our project, we have established approximately a 30% tops of missing data that we can allow for a variable to have in order to keep it within our data analysis. However, this can change depending on the flexibility of the person that's analyzing the information. On the other hand, in many of those data sets, there are many redundant variables like the dates, where they assess the duration of the cycle based on um, plantation and harvest date. Also, the geographical coordinates that are closely related with the location, like the department or municipality. There are also other variables like yield that are the product of an algebraic calculation between other variables. In this case, a production unit on an area production. In this regards, we could help the model to choose in each one of the cases the variables that we are interested to keep. This depends on the criterion of each one of the researchers that are analyzing the data set. Since this is one of the last criterion to remove variables from the data set, now let's go and see the transformation step. First, these are the variables that should be added or they have to undergo through a process that's called summarization. That's going to be shown in the deep layer package. One of the most frequent cases would be for fertilization, where several producers can have different strategies in place in order to carry out the fertilization process. Some can go twice throughout the whole productive cycle, others more. And there they could register the times that the producer goes and the amount of fertilizations that are applied in each one of those times. This could be transformed by adding it or adding two new variables, one that calculates the frequency of each one of the producers and how many times they fertilize, and we can also accumulate the values, the total values in the end of the productive cycle, in this case for fertilization. The variables that are registered is several times. We have fertilization, chemical and organic fertilizations, monitoring, everything related to climatic variables, irrigation, and other tasks that are performed on the crops. In the case of climatic variables, the challenge could be even bigger because these variables have an even smaller scale. For example, many stations report daily information and take into account a productive cycle, like for example for rice that has a total of 120 days. If we eh, if we put it as a columnar data set, it would be 120 variables per each one of the main variables that we're working on. Minimum temperature, maximum temperature, precipitation, and solar radiation. So in that case, the ideal situation would be to transform this data by adding them to climate indicators, like for example, the average of maximum temperature, the average of minimum temperature, the average range of temperature. We can even establish other indicators with experts, like for example, accumulated degrees. This would be the amount of degrees that are registered based on the temperature threshold. Other variables like solar energy that's accumulated throughout the whole 120 days of the cycle. Other variables that require transformation would be the dates. Usually, the dates can be understood by the system as categorical variables. And if we have a large dispersion between those categories, the model is going to have a hard time analyzing them in their original form. So the ideal situation would be to apply some transformations that will help us to maintain the information on when it was planted, when it was harvested, and we can transform that in days of cycle as we saw before. And we can also use transformation to calculate the Julian day, which could give us more information about what are the most effective moments during the moment where the producer can cultivate in order to have the best yield. Other variables require algebraic calculations. If they are not from the beginning, we can also define that some of them would need to process information, for example, with the case of yield that we also mentioned before, and would also have to get the division between the total production and the cultivated area. Other variable that requires processing would be qualitative variables that have many different categories. Since it's very complex for the model to process several variables that are qualitative in nature, that have many categories, and the ideal situation would be to identify a way to group some of those. And that would be the case of the variables that are registered. So we could have a conversation with the experts in order to assess if it's okay to group some of them, like, for example, criollos or Creole, the KLB, and try to reduce the complexity that the original model has. Sometimes it's also necessary to create a category of others in order to group categories that have a very little frequency. In this case, we maintain categories that should be repeated at least 30 times in the data set. Every time we take a decision about removing or transforming a variable, we always emphasize on the fact that we have to get support from the experts in order to decide which action we're going to apply. And this is because every decision that we take at this moment could affect the results that we can generate. And it can also affect the information that we could supply during the decision-making process. So in order to have to go back in the analysis just because we made a modification that wasn't done responsibly, the idea is for us to have a discussion with the experts. The common variables that are maintained in the database, due to the experience that we've had with several projects, would be weather, uh, temperature, information, diurnal range, solar energy, precipitation, humidity, and the soil, all chemical and physical properties. The ones that are most common would be the texture, silt, clay, organic content, Cajun exchange capacity, the saturation or basic saturation, drainage, and in agronomic management, fertilization, the different varieties, the seed treatment, type of tillage, applications. All this depends on the strategy that we have stated in order to analyze our data. Obviously, it's also important to have the yield information and profitability information. Having said this, I would like to end this section for variable transformation and selection criterion. Continue watching the rest of the videos.